Good morning, and as always,
Slow is smooth, smooth is fast.
solving problems. So, up until this point, you guys have solved problems in chemistry, you've solved problems in biology, and you've had a specific way of doing that. And we are going to build on chemistry, we're going to build on biology, and we're going to ask you guys to do a very specific way of solving a problem, which means this is a perfect point to reference if you ever have to solve a problem and you don't remember how to do it. So these should be prevalent in your notes of what you should do.
Now, this is going to feel like too much work, but what I can guarantee you is that if you take your time and you go slow and you follow these steps, your work will appear smooth. And what will happen is you will avoid making errors, mathematical mistakes, confusions, and applying misconceptions. So you will actually be done with your work faster than someone who just tries to rush through.
And it's actually really good for us if you ever have a question that you need answered or you're working in class, because the first thing that we're gonna come over and try and see is this. And because this makes it easier for us to find mistakes, and it makes it easier for you to find mistakes. And without this process, and the reason I'm saying this process is because this is the one that we're giving you. Without this process, we can't find the mistakes that you make, and you can't find the mistakes that you have made.
Yeah. And again, I just want to emphasize this because, again, I know it's going to feel like too much. In all 4 years that I took physics in undergraduate to get my degree, this is what I used, this process. And when I solve problems today with you in class or tomorrow with you in class, I'm going to use this process. This is the process that I use. So if you feel like, oh, Mr. Roberts, you know physics so well, if I know physics so well and I use this process, it's a good process for someone who's learning physics to use it.
All right, so the first step we need to do is we need to write the problem. And we have another of those green asterisks. So what are we going to do?
Yeah, so we're really just understanding that when we do homework, this is that time when we want to write the problem. And really the benefit is that way, so this piece of paper actually becomes a thing that we can look at. So now we're not saying, hey, I need help on this question. Oh, it was, chapter 3, number 30. We say, hey, this is it, and here's the problem. It's written neatly. The other nice thing about having that problem neatly written is it helps us identify. Think about annotation in all of your English classes and in your biology and chemistry class. Well, we're going to, in essence, annotate the problem by identifying important things. Now, the reason that asterisk there is we're not asking you to do that on like a multiple choice quiz. We're asking like that you can kind of skip this problem. But anytime there's a formal representation of your work, you want to start by rewriting the actual problem.
So if I were to write these notes, I would kind of break it up into two different ways: homework and class problems.
Mm-hmm. Certainly in class, because you want to be able to go home and any problem that's introduced, be able to reflect to it.
I would say complete write-up. Complete write-up, and that includes annotation.
Absolutely. We'll talk about that in the next step.
Quizzes and tests. What we're going to be talking about is an abbreviated.
Yeah. And really almost like steps 2, 3, 4, and 5.
So let's start walking through what we do after we write the problem.
Once you've written the problem, I'm going to actually make a 3-column heading, and sometimes I'll make a 4, and we'll show you where that is in the place. And it's my knowns, my unknowns, and my equations. And sometimes you can shorten that as KUE. I'll always write those words, but that's not something that has to be done by everybody.
And then from there, we start to fill in those spaces. And so we list the value, the variable, and the unit, which is the unit is and it falls under the variable, but this value needs a unit. All values must have a unit or else they mean nothing. We have no idea what you're talking about. The variable is what that representation is. So in math, you typically see x and y. We're talking about whatever our variable connects to, and you want an equal sign showing where the connection is. Just having a list of values will do you no good.
Yeah. Then once we have kind of the information that's been provided, and sometimes we'll go back to that problem that we've written, and you might, if you want, you can kind of like circle those values, like this is what I know. Usually to understand what we need to find, the unknown, it's a word. It might be like, what is the time, or solve for acceleration, or with what force. You can kind of hear that question involved. But then you write the equation, or you list any equation you may need.
So do we have to just list one equation?
You know, yes and no. And this is where we want to add to this. Initially, you're going to list every equation you've got in front of you. And then you'll look at an equation, and you'll look at your knowns and unknowns and decide if the equation matches. And if it doesn't match, you'll go to the next one. And you'll basically go until you find the right equation. When you get better and better, really, and when you just get more smooth, and your smooth can become more fast, you'll understand, oh, this is the one equation that I need. So there might be times when Mr. Schmidt and I, or your other physics teachers, write one equation, and we're just kind of driving through the pile and going straight to it.
And then finally, solve the problem. This is where we're really writing each and every one of our steps. And we have this additional part that we want you to explain your steps. Because if you can't explain it to yourself, it's probably not a good step.
And so this is going to be the one area where you're feeling like we're really making you do too much work. You're saying, well, if I've done the math, why do I have to say that I, substituted my variables, or I've reduced, or I did this? And the reason we're doing that is because, again, if you can explain what you're doing verbally and you can write it mathematically, we have the narrative and we have the mathematical. And this also just helps us understand if what you're writing mathematically is what you're actually thinking in your mind.
And then finally, state your answer. And by that, you're actually explaining what your answer is. You're saying that an answer that I found the maths to be this. And that whole sentence is really important in the sense that you're identifying that this is not only your answer, but you actually understand how that connects back to the original problem.
Yeah. So we have an example for you, and there are very little numbers or words. But the problem reference, so you might see like chapter 2, problem 48. That way, again, we all know where it is, and it might be that like I've made mistakes copying a problem down, and so that way at least we can go back to where it was. Or you may say like, October 3rd in class.
And then once again, knowns, unknowns, equations, and this last one, picture.
So again, I said like sometimes we add that fourth column. There are times when drawing a picture, and what we're going to eventually introduce this thing called a free body diagram, is really helpful. If you don't feel like you need a picture, you don't need to have that empty slot. You can kind of neglect it, but we just want to really emphasize that eventually it's going to show up.
And then, so under our knowns, unknowns, and equations, we're going to have any variables or any equations that we're using. So each of these three equations would be actually up here as well, but you would start to rewrite them and tell me why you're rewriting them. So the F equals ma, force equals mass times acceleration, we'll talk about this later, would be I'm introducing this equation because I have mass and acceleration, and I'm plugging these values in.
And then we've kind of got that final thing where you're coming back and saying, hey, this is what I was asked to solve for, and so this is it. Now, what we just want to emphasize, can we bring it down just a little bit, is we have a problem, main idea, evidence, link, conclusion. It's like a Melcon. And I know that we drive this idea of Melcons in our writing, so we can even see that same thing. The main idea is all that information and what we have. Our evidence is our math. Our link is explaining it. And our conclusion is the reporting of the answer.